Hi there, this is Dr. Pan recording from Tucson, Arizona. Hope life is treating you well. Thank you for watching this clip on solve for our roots. We have a z to the cube plus 8 equal to 0, and we're going to use de Moivre's formula. Hopefully I didn't butcher his name too badly. He's a French mathematician, Abraham. Anyhow, let's get started. So we have a z to the 8th equal to minus 8. Let's put it into the complex form, so it's r e to the I theta to the third equal to, I'm going to put 8 e to the I pi. The reason is I pi is this side is negative here and it's 180 degrees. And technically I should write a 2k pi over here where k is equal to 0 plus minus 1 plus minus 2. Now when we're solving for a cubic root here, when we divide over our k, specifically actually just going to have 3 of them, 0, 1, 2. Alternatively, you can have minus 1 plus 1. And as we get closer, I'll explain why they're really the same. Okay, for now, let's equate r 3 theta, oh, this is e, is equal to 8 e to the I pi plus 2k pi. And then let's split it up. So r to the third equal to 8, and then 3 theta is equal to pi plus 2k pi. Okay, so from here, r is equal to 2. That's pretty easy. And then here I have theta 1 equal to pi over 3. Theta 2 is equal to pi over plus 2 pi over 3. Or theta 2 is equal to pi. And theta 3 is pi plus 4 pi divided by 3, or theta 3 is equal to 5 pi over 3, or alternatively it's pi plus 2 pi over 3. Okay, now going back over here, why those two are the same. The principal one here is pi over 3, which is 60 degrees. It's right over here. This is our complex plan. All right, this dividing this 2k pi by 3, actually we're dividing the circle by 3 parts. And the next one ends over here. The one after that ends over here. So if you think of this one as k equal to 0, you can do k plus 1 gets you over here. K equal to 2 gets you over here. Alternatively, you can think k equal to 0, k equal to 1, k equal to minus 1 gets you over here. So k equal to 2 or k equal to minus 1 gets you to the same position. Okay, now most of the textbooks use the positive one, and I think it's because it's easier to say, look, if it's a cubic root here, which is n equal to 3, you stop at n minus 1, which is, in our case, is 2. Anyhow, so once we get those thetas, we can go back and find each one of the roots. Now, before we do that, today is Friday, and someone pointed me to this random funny pictures for you Friday. So here's your math break. Okay, I apologize ahead of time if someone gets offended, but it's just too hilarious to not show you. I don't know, is it a man or dog, or maybe man's best friend? Maybe they're the same. Anyway, okay, back to math. Our z1 is equal to r I theta 1. So we're going to put a 2 back in there. And then now we're going to have cosine pi over 3 plus I sine pi over 3. In our case, is 2. And then a half plus I radical 3 over 2. So 1 plus I radical 3 is our first one. Okay, let's go on to our next one. Z2 is equal to r I theta 2. And this one is easy. That's a minus 2 because I pi give you the minus sign. Now Z3, we'll have r e to the I theta 3. 2 is here. And then I would have cosine. Now this one is pi plus 2 pi over 3 plus I. It's a little messy here. Sine of pi plus 2 pi over 3. The reason I've written in that one is I can use my reference angle. Pi doesn't really change my angle value. What am I thinking? Today is Friday. It's a long day. All right, so over here I would have cosine of 2 pi over 3 plus I sine of, let's see, I better be careful here. 2 pi over 3 pi is over here, and I would end up in 4th quadrant. Maybe I should not do this. This is too risky. And that's just over here, 90 degrees. So I would have half over here, radical 3 over 2 with a minus sign. Okay, that's probably a safer way. Is equal to 2 times cosine is always the x value, so it's half plus I minus radical 3 over 2. So our z3, the last one, is equal to 1 minus I radical 3. So here's the roots. There's 1 here. There's z2 is equal to this one. And then z1 is equal to this one. So here's the 3 roots. All right, that's how we handle this type of problems. Once again, from Tucson, Arizona, this is Dr. Pan, making learning math fun, at least trying to. If the video has been helpful, I would appreciate a comment or a thumb up. Until next time, have a confident day.